Okay, class. So hopefully after we get more comfortable with the idea of how scale factor affects surface area and how scale factor affects volume, we actually don't have to keep calculating every time the ratio, because if you just know how it affects it, you'll know the shortcut to it. And I'll explain what I mean by that. So number 15 says, a rectangular prism with side lengths of 5 yards, 10 yards, and 15 yards is reduced by a scale factor, resulting in a new sides of 1 yard, 2 yards, and 3 yards. So one thing that we have to remember, class, is that scale factors can also decrease the original side length, and it's kind of like zooming in and zooming out, right? If you want to zoom in, you would increase the side lengths, but if you zoom out, then it starts to look smaller and smaller. So in this case, it's a reduction, and you went from, I'll go ahead and draw this, right? A rectangular prism. Try to draw this accurately. That kind of looks like the, oops, sorry. It looks like that, 5, 10, and 15. And now it becomes a 1, a 2, and then a 3. So it kind of looks like a stick of butter. Yes, I am thinking of butter right now. Okay, so this is 1, 2, and 3. So you can see that it got smaller, and it got smaller by a, now, one thing that we could also do to calculate scale factor is we always do the new dimension divided by the old dimension, right? So just because it's smaller doesn't mean it's not the current or new, right? So in this case, if I were to compare the bottom base 1 with the 5, I knew that the scale factor is 1/5. And you can say that a scale factor of 1/5 means that the new image or the new object is 5 times smaller, right? What would the new surface area be and the volume be for the new prism? Well, how do we do that? Wow, we should probably calculate the surface area, and that alone is a lot of work, and I'm gonna go do it right now. And if you still are not comfortable calculating the surface area of this rectangular prism, I'm going to label this as old, right? So, you definitely want to review the previous lesson, because this is on scale factor and the previous lesson was on surface area. So here's another shortcut to calculating the surface area, class. Okay, so I know that this is 5 times 10. I know that there's also obviously a 5 times 15. And then the last combination that I haven't used for a rectangular prism, remember this can only be used for rectangular prisms, is 10 times 15. I could do this so quickly because I just know that 5 times 10 is one pair, 5 times 15 is the other pair, and then the third remaining pair is just 10 times 15. So this is 50, 75, and 150. Now remember, these are only the 3 faces that we could observe, but you basically have to double it, because if you have a face on the front, you have a face in the back. If you have a face on the right, you have a face on the left. If you have a face on the top, you have a face on the bottom. So I'm doing this and I'm just adding it up, and I end up getting a clean 550 yards squared. That's my original surface area. Well, now we know that this new surface area, I'm going to put a line here so we can see, this new surface area is going to be significantly smaller, right? It's because the scale factor is 1/5. So I'm going to run down very, very quickly how to do that again. 1 times 2, 1 times 3, 2 times 3, 2, 3, 6. Add these all up, which gives me 11, and multiply by 2, which gives me 22. And you're like, wow, Mr. Quo, the surface area of this new one is only 22 yards squared. The surface area of this old one was 550. That's a lot. That's a lot smaller. How many times smaller is 22 compared to 550? Well, let's see. It's 25 times smaller. That's not a coincidence. Because, so you would say, since the scale factor was 1/5, the surface area is 1/25 of the original, and the volume is 1/125 of the original. Okay, this has everything to do with the scale factor either being squared, 1/5 times 1/5 is 1/25, or the scale factor cubed is 1/5 times 1/5 times 1/5 is 1/25. 1/125, I mean. Okay, you just got to know that shortcut. And the shortcut really is just square it and it will affect the surface area, or just cube it and that's how it will affect the volume. Okay, I think that's enough material for the day, class. I don't want to overwhelm you with this. I know that this is a very difficult concept, class, so just please try to review this and do your best with this. I understand if you are confused. If this is troubling for you, please don't feel that you are alone in this. I understand that this is a very difficult topic, and I just try your best. And I wish we were in class because I would be able to explain this in more detail. But try the homework that we provide for you today. And of course, if you have any questions, come see me during office hours. The rest of the lesson is good, but I don't want to overwhelm you with material right now. Okay? So if you want to try the rest of the lesson, by all means do it. Like sometimes it's just good practice. Like now that I'm looking at 16, I kind of like it. And I'm going to do it if you want to continue watching. But I also think up to this point is good enough. Okay. A rectangular prism with side lengths 2, 3, and 5 is enlarged by some scale factor. Okay, so it's a rectangular prism that's 2, 3, and 5, and I keep drawing the butter pieces. 2, 3, and 5. Okay. The volume of the new prism is 240. Well, first of all, what is this volume? This volume, the current volume, is 2 times 3 times 5, which is, what is that? 30. So this is 30 millimeters cubed. Now, if I told you that the original volume was 30 millimeters cubed, and all of a sudden I said the new volume is 240 millimeters cubed, does that mean that the scale factor is 8? No. I know you're thinking 8 because 240 divided by 30 is 8, but that doesn't mean that the scale factor is 8. Now, the volume is 8 times larger, but we also know that the scale factor cubed should be the ratio. So if the scale factor cubed is 8, that means that the scale factor must be 2. Is 2, right? Because 2 times 2 times 2 is 8. So that means the length of the new sides should be 4 by 6 by 10. And if the length of the new sides is 4 by 6 by 10, what is the new surface area? Wow, so they're telling us to do surface area again. 4 times 6, 4 times 10, 6 times 10, 24, 40, 60. And then you add this all up, class, and you then divide or multiply by 2. So you get 64 plus 60 is 124 times 2, which is 248 millimeters squared. This is definitely supplemental work. If you stopped where we stopped, that's okay. Just practicing for the sake of practice at this point. Okay. Please let me know if you have any questions, and I hope to see you all in office hours. Okay. Good job today.